In the figure below, the larger circle has a radius of 6, and the smaller one has a radius of 2. And then they asked me what's the approximate area of the gray region. But how do we calculate the area of a whole circle? Let's just start there.
Or pi times radius squared, right?
Pi r squared, yeah. So that's the area of the whole circle. So how would we calculate the area of half the circle?
Oh, just put the 1/2 in front of it.
Right. What about a quarter of the circle?
Just put the quarter pi r squared.
Yeah, so for any percentage of really any shape, and this doesn't even just limit to circles, but if we could get it down to a proportion, an exact proportion, we would just add that to the front of the area of the whole figure, and then we'd have our answer, right?
Yeah.
Okay, so let's try to do that here with this question. We see that we have the radii for the smaller circle and the bigger circle. And those are definitely going to help us, but they're only really going to help us calculate the area of the whole circle, either the small one or the big one, or maybe just the disk in the middle, right? But
yeah.
we need some way to figure out the proportion that is that gray area. What else? What other information do we have in the figure?
The 30 degrees.
Yeah, the 30 degrees is going to help us figure that out. What are we going to use? How can I turn that measure into a proportion of the total circle?
Ooh, can you just do 30 out of 100 or no?
30 out of
10.
That's close. You're getting warmer. So the circle doesn't necessarily have to be out of 100% because degrees don't really readily translate to percent, right?
Oh, okay.
So, but what is there something that we know about a circle in its totality that we could kind of use to relate a degree measure to the proportion?
Oh yeah, isn't it like 360 degrees?
Yeah, 360. All proportions of a circle can be represented as some degree measure out of 360. Like if you wanted the whole circle, then 360 out of 360. Or half the circle would be 180 out of 360, right? So if we got a proportion, we'd have x degrees out of 360. In this case, we have this, which is equal to, what's that, 1/12 of the circle? Let me double check, because coming off a holiday weekend. Yeah, 1/12 of the circle, right?
Yeah.
So then, all right, so now we've got that established. We're looking for 1/12 of, let's flip back to the question. It's not 1/12 of the big circle or the little circle. In fact, it's the middle ring, right? The disc around.
Yeah.
So how do we account for that? So if we've got this gray figure, right, this very popular question where they'll highlight, like they'll have a big one and then a little one, and then they want the one between. How, if we could figure out the area of the big one, like let's say we just had the area of the big circle, could we figure out that space in the middle somehow?
Would you just do 1/2 of the larger square?
You're on the right.
Or the radius?
We could do something like that. Yeah, you're getting warmer. Keep going. I'm going to try to extract this one from you.
Okay.
Because I think you know how to do it. I think if you think about it for a second. We've got the big radius and we've got the little radius, so what can we do?
Okay, could you find the percentage between both of them and then multiply that to the 1/12?
You are getting so much warmer. I think there's a little bit easier way than don't think about a proportion. Just think like if I had the area of the big circle and then I had the area of the little circle, what could I do then? I wish I had a hole puncher right now.
Oh, subtract?
Yeah, if we had them both and took the difference, that would leave whatever that small disc is, right?
Oh, okay.
And I want to make it clear, you would want to actually calculate that whole area of the big circle and then the
And
area
then
of the little
subtract
circle
between
and
both.
subtract those, because I don't think the math works out if you just calculate it as the area of a circle with a radius of like whatever the difference is. Let's find the area of the big circle. What would that be? You already told me before the area of any circle.
360.
Well, the area of any circle is pi r squared, right?
Oh, pi r squared, yeah.
So then what would we plug in to find the area of the big circle? It'd be pi times what?
R squared.
Right, which for our big circle is, what's the r?
Oh, 36.
6,
Or,
right?
okay.
Oh, did you already square? Is that what you said? You squared it?
Yeah.
Okay. Like that, right?
Yeah.
Okay. So then what about the small circle?
4, pi 4.
Yep. So then the area of the whole disk would just be the difference between those two, right?
Yeah.
Okay.
Okay.
So then how do we find the area of just that gray part of the disk? Do you remember what portion that was?
112. Okay, so it's 112th of whatever 32 pi is.
Right. And then the multiple choice asks us for an approximation of that, so that's where we're going to need our calculator. I know you can't see that calculator super well, so I'm just going to do this here. 32 pi divided by 12 is
Okay.
8.377. Answer D. Let's do another one here. I'm just going to make this one up just so we can kind of hammer this one home. Let's say this is 10 and we'll say this is 6. And then I want you to tell me what this red area here is. All right, I'm going to work it on my own, but I'm going to flip to the camera where you can't see what I'm writing.
Okay, perfect, yeah. And then is this a square or rectangle?
That's a great question. It will be a square, even though it does not look like one.
Okay. Okay, I think I got it.
Okay, how'd you do it? Walk me through.
Okay, so first I found that the area of a square is a squared, or area squared. And I squared 6 and 10, and then subtracted 100 and minus 36 are the two solutions to those, and then got 64. And then I just put that as a shaded area.
Okay, so you did 10 squared, you did area of the bigger square minus area of the smaller square, and then what'd you do? Was that it?
And then I just left it like that.
Okay, there's one little small problem. Let me zoom in here because I want to see if we can figure it out before I show you. Is it the whole square that we're looking at?
Oh, no, only half.
Yeah, half of it, right? So half of 64.
Oh, okay.
Yep. That's almost always when they do those gray region questions or whatever, they almost always will give you some portion of the figure. It won't be the whole thing. So like go ahead and kind of instill that in your head that like it's almost never the area of like the whole disc or the whole square or whatever it is, right? It's going to be like be on the lookout for some kind of quarter, half portion, something going on.